But let's be smart. Let's be smart. Let's be smart and I have a special device. It's a very dirty one, but it works. There's a temperature regulator. It is a furnace with a solder poodle inside of it, and the principle is, it's a very dirty concept, but nevertheless, here is a special hole for the temperature probe. You have, okay, and then we will switch it on, and you will observe I keep it in a kind of container because this liquid molten solder might pour off or come out of this furnace, and I don't want to be in a position of being burned by this solder. So let's start it. Okay. The temperature is set to, I don't know if you can see, but it's 268 degrees. Everything is very dirty and okay, let's film how it gets warm. Temperature is rising. Now it's 13 degrees centigrade, 14 degrees, 14 degrees, and temperature is rising, 16, and so on. But when the device will be in an operating condition, this molten pool of solder will rise above the level of the furnace, and it will be kept in by the surface tension, concave or convex. Convex, I think. It will be upward, so upward enough to me to touch those contacts with the molten solder. Wait a certain amount of time, use pliers and extract such a long connector from the board. There is also an idea: if you extract it, you can inspect the contacts if they are straight, and if you're lucky enough, you can put spare one in a one operation without need to clean the holes. But I did not try this. Only my try was with this testing board. So I did extract those two PCI slots, and the outcome is such that it looks like this. I don't know if I would be in a position to put it in a one straight move. I also extracted with this furnace other sockets. I also tested my abilities to remove BGA parts. I removed those USB contacts without any damaging them. The only damage was when I tried to remove, where is it? The ATX power socket was removed without any damage, but damage was to the floppy and FDD. Those parts have very soft plastic bodies, I would say. That's it. We will test. We will remove those two sockets. We will remove this also, and I'll try to remove this upper lid, but I don't know if this is the same one, if it will fit to this board, because this board has a metal lever and this board has a plastic one. We will see. So now it's 96 degrees centigrade. It's hot. Believe me, it's hot. I will make a time lapse of it, of moltening this furnace load. So it is called the solder pot. Not solder, but solder pot. Solder pot, and there's a method for removing components and soldering them back with this solder pot. The solder pot is a rather lengthy one. I did it deliberately to be able to remove long sockets. This is about 1 inch deep, so it is a lot of soldering in there. But it's now 127 degrees. Believe me or not, but it's hot. So we have to wait. Here is a, how do we call it in English, when the molten metal contracts, it forms a cave. Here's a cave. Let's wait. There might be a problem if there are some components like those, because they might be desoldered from the board, but I'll try to keep this part in contact, so not to desolder those capacitors. Now we have 53 degrees centigrade. I'll use the pliers. Those capacitors are here, so it will be like this. I will lift it. Hopefully it will be a success. Maybe I have to replace the relay, because this relay might be not powerful enough for this operation. So because I hear it struggling to switch. $160. Come on, it's an old regulator. Scrapyard find. Oh, come on. Yeah, I have to put the stronger relay. 65. 66. Believe me or not hot. 68. 69. Oh, I don't know if you can see, but some magic starts to happen, because I see here's in this cave I see a molten metal. The problem is I forgot to mention that this device must be leveled. Ooh, I forgot about it. Ooh. What will be now? Because it must be leveled. I designed this kind of leveling mechanism, but it's not so. It's not so. Oh, you can see here's molten solder filling the cave. So it is expansion, expanding liquid. $194 on this temperature regulator, but I think it lies. I have to put something, because my oh, you see, it's not so leveled. Oh, I forgot to make it properly operating, so I have to use something to correct it. Okay. No. So you can see now the liquid. It is a liquid. I can even skim it. But we'll wait. What is the real temperature of this now? Let's see. It measures, the hottest points are about 240, and my regulator gives me 246 now. So it's almost the same. So you can see or not. The regulator is set to 268. So let's wait. I add some oh, the regulator started to regulate. So now that's it. Farewell, Mrs. Farewell. What about removing this one? Let's remove this one too. I'll put some flux. Yeah. And then where are my pliers? Oh, there are some contacts left. Not good, mister. Even this part is. I lowered the temperature by 5 degrees, but it is very. Some solder left the puddle. That's not a problem. I can fix those. I can put them back. I'll show you the method. But this one is broken already, so it's not a thing now. Here is the removed AGP. It's a broken one. Okay, never mind. Let's address the donor board now. Where is the donor board? Donor board is here. Let's start with AGP. Temperature might be too high or not. I don't know. Where are the pliers? Pliers, please give me the pliers. I want to put back the solder that left the puddle, because I used all the solder I had. I bought a big bars of leaded solder for this purpose, and it took more than 2 of them to fill this puddle. Let's put some flux. Okay, there is a flux. Fluxy flux. So 1, 2, 3, and this one is also not in a perfect condition. There are 2 of them that look displaced. So now 1, 2, 3, off you go. It does not want to go. Why? Let's repeat it. Off you go. One stayed. Phew, phew, phew. I think I'll have to make the temperature higher. Let's make it wider. So one was left. Okay, let's remove those, all of them. Put some solder, not solder but flux. Ah, I forgot to do something special. For it. You see? It will be brutal. For cleaning the some flux. Two went, 2 more to go. One is still in. Okay. Whew. A lot of smoke. Only one. But all of them went. I did not even displace those parts that are near those connectors. So if we are at this point, let's play and remove all those PCI slots. Firstly, let's clean the wire brush. Then add some flux. Okay, I will play with it in order to desolder and quickly solder it in place, just to see if it's possible. Temperature is now 270 degrees. Okay, let's remove those. Okay, now pick. Off you go. And then you're in. Yes. It's a brutal method, but might be working. One off. Oh, a lot of smoke. Another one. You can see the capacitor is off. Off you go. Another one. Capacitor is off. Off you go. Off you go. Capacitors off. Another one. Oh, a lot of smoke. Off you go. I have to press it against the Off you go. And the last one. Capacitors are off. The connector is off. Ta-dam! Ta-dam, ta-dam! As you can see, it's a very efficient, I would say, quick method. And I have all of them desoldered very nicely, except one pin here. Some capacitors even went very easily, and those those let's oh, nothing went down. Okay, what shall we do next with the drunken solder? Okay, let's no, I won't do that now. Okay, I'll switch it off and have to wait for it to cool down. 1000. But I could also desolder those capacitors with this device. I'm putting flux on them, and then I'll use this stand off. Okay, now off you go, off you go, off you go, off you go, off you go. Very potent method. What about this one? Off you go. One left. It's not good. Now off you go, off you go. Puddle is not high enough. I have to okay, let's continue. Let's continue, mister. Off you go. What next? Those two are on the bent part. Okay. Here's one more. Off you go. Okay, that's it. That's it. Not. Oh. That's it. Okay. It's a floppy. One was left there. Okay, let's inspect the outcome. Here's one. Here's another one. Those are the 2.5 volt sockets. Here are the 3.3 sockets. I would say they are in a very good condition. What about this one? Here you can see the was not molten enough, and the one pin was stuck in the board. A lot of dirt, but otherwise, here are those pins that are, where is it? Here are those pins that are displaced. I don't know why. Maybe I'll manage to put them back. Okay, what about the broken one? You know, it is a good to have a spare amount of those broken ones, because you can replace some of them. I was here too quick, because you can see there are some solder that is remaining. Okay.